In this video, we're going to look at how to apply the first three exponent rules to simplify these expressions. So the first three exponent rules involving multiplication. The first one, if we have x to the nth times x to the nth, so because they have the same base, we're going to keep the base x and add the exponents. The second formula, if we have these two exponents, m and n, right beside each other, that means you have n m's, we multiply them. And the third formula, if we have one exponent that's shared by x and y, and its multiplication inside, it's kind of like we're distributing exponent to both of them, so we get x to the nth and y to the nth. Okay, so now let's apply these three formulas and on these examples here. And notice that here we are mixing the numbers and the variables. So between all of these are multiplications. And multiplication has a commutative property. If you remember the multiplication, let's say 5 times 6, it's equal to 6 times 5. So you can change the order and multiply, then you will get the same answer. So in this case, we could do a lot of switching. So for example, I can switch -4 with y and then with x squared. So I will have -4 and -3 together. And then I can switch x with this y, and now we have x squared and x together, and y by itself. So the reason I do this is because inside the parentheses, there's nothing we can multiply. -3 cannot be multiplied with x squared. X squared cannot be multiplied with y. We cannot really simplify this expression any further. But if we use the commutative property, and we can multiply -3 and -4 to get 12. And x squared and x, again, by the first formula, remember, if we want to use the formulas, they must have the same base. So that's why I have to put x and x squared together. So they have the same base, and I just need to count the number of copies. And when we have x, it just means we have one copy of x. So if you got 2 copies of x and multiply with another copy, that's total of 2 plus 1, which is 3 copies. So that's how we get the answer, x to the third. Again, 12 comes from -2 times -3, and x squared times x gives us x to the third. And y, because there's nothing to multiply, so we went ahead and just bring down the y. Okay, next, so these two give us this, these two give us that, and y is brought down. In the second example, we're going to be doing the same thing. So first of all, we cannot multiply 7 a's and b's and c's, but if we switch things around, we're going to have 7, 9 together. A squared, this is the only one with a's. We don't have any other a's, so put it by itself. But we got this one has a b, base b, this one has a base b. So we're going to put all the b's together and the c's together. So first to rearrange everything. If you are able to see everything in your mind, you don't have to write this down. But if you have trouble seeing, because there are a lot of things here, in case you forget something, maybe you should write down, reorganize everything and write them down. So now we have 7 times 9, that's 63. A squared is the only thing, bring it down. But when we multiply b third and b fourth, again, it's the first formula, same base. So if you get 3 copies of b and 4 copies of b together, you get 7 copies of b. And same thing here. You got 1 copy of c. Again, if there's not an exponent, it means you have 1 copy. 1 copy of c, and then you get another 5 copies. Together, you get 6 copies. So that's what we got. This comes from 7 times 9, a squared bring down, and 3 copy plus 4 copies, 7 copies of b, and 1 copy plus 5 copies, that's 6 copies of c. Now, in the next example, we'll be doing the same thing, but we have a bunch of negative numbers, so we need to be careful with multiplication of them. So I already reorganized everything, put all the numbers together, all the a's together, and all the b's together. And when we multiply the numbers, -3 times -2 gives us +6. And then we're going to do positive 6 times negative 5. That gives us negative 30. Okay. And then a squared times a. A means 1 copy of A. Again, B means 1 copies of B, 1 copies of B, 1 copy of B. So now you have 2 copies of A plus another copy of A. That's 3 copies of A. 1 copy plus 4, that's 5. 5 plus another 1 copy, that's 6 copies. Now, in the next example, we have some fractions, but fractions are still numbers, so we can multiply the fractions and the A's and the B's separately. So we got these A's and we got B's. So I put them together. Now, when we multiply fractions, first of all, these fractions are negative, so 2 negatives make a positive. So go ahead and get rid of the sign, so because negative times negative is positive. And next, we're going to just multiply the fractions. So I'm going to do the fractions here, 6, 7, 21 over 2. And when we multiply fractions, you can multiply straight across, or you can reduce the numbers first, because 2 and 6, they have 2 in common. 2 divided by 2 is 1, 6 divided by 2 is 3. 7 and 21, they have 7 in common, so I'm going to divide both of them by 7. So now, after I reduce all numbers, I am going to multiply them straight across. So 3 times 3 is 9, 1 times 1 is 1, and 9 divided by 1 is 9. So that's how I got this 9 right here. Now, to multiply variables, we just need to apply the formulas. And 2 copies plus 3 copies, that's 5 copies. 3 copy plus 1 copy, that's 4 copies. Okay, next we're going to look at, so right here, all these 4 examples we had only involved the first formula. So now we're going to look at some examples involving the second and the third formula. So in this example, we are going to have to use the other 2 formulas. So let's look at the problem. Now notice that we have a box. So again, imagine the parentheses as a box, and then the box has a exponent. So it's kind of like a box has an exponent. And if you remember the third formula, when you have something like that, you have to distribute the exponent to everything in the box. And in the formula, we only had x and y's, so you can distribute the second exponent to x and y's. But if you have more than x and y, you have z or any w, you also have to distribute exponent to z. So everything in here needs to be raised to the second exponent. So that's what we're going to do first. Now, minus sign and a 5, I'm going to treat them together. So this is the first thing in the box. And then there's also a to the third, and there's a b seventh. So we need to distribute the exponent to negative 5, which gives us negative 5 squared. And then we're going to distribute the second exponent to a third, because a third it's more than just a single letter a, so that's why we have to put them in a pairs parenthesis. And then b7, put it in a pairs parenthesis. So we're going to distribute exponent to each individual one of them. Okay, so I'm going to actually get rid of this because I already have this typed. So as you can see here, I distribute the exponent to everything in the box. Now we're going to simplify this further. So I did say this step you may be able to skip if you can do this in your mind, but if you can't, make sure you write down this step. So now we're going to work on negative 5 squared, and that's something we did previously. So that 2 means 2 copies. So 2 copies of everything in the box, which includes this minus sign. So we're going to do negative 5 times negative 5, that gives us positive 25. And to do this part right here, and remember, this is the case of you have another box, so you got 2 boxes, so each of them contains a third. So, or think of this as 2 threes. If you have 2 threes, you do 2 times 3, which gives you 6. And in this case, you have 2 sevens, and you do 2 times 7, that gives you 14. Okay. If you're not familiar with this process, don't skip the first step. Because some students, they thought they need to do addition 3 plus 2 when they skip the step, because they're thinking where they're not together, they're not beside each other. Well, the reason they're not beside each other because we skipped a step. But if you distribute, after you distribute, you can see they're beside each other. So you have 2 3s and 2 3s of A and 2 7s of B. So you do have to do multiplication. So here's another example similar to what we just. This one actually is a little easier. So again, in the box, we have -2. We also have x fourth, but we have exponent 3 to the whole box. So which means we have to distribute 3 to -2 and 3 to x to the fourth. So this is what we got. And now we work out at -2 to the third, and that means we have 3 copies, multiply 3 copies of -2. So -2 times -2 is +4, and +4 times -2 is -8. So this will give us -8. And to work on this part, again, it's like we have 3 fourths. 3 fourths means 3 times 4, and that gives us 12. And the base x, we will keep it. So we're multiplying the exponents 4 and the 3 to get 12, and we keep the base x. And these two examples are more complicated. And so we can see, first of all, we have those exponents that we need to work on first. After that, we also have to do multiplication between them. So first, still follow the order of operations. Please excuse my dear Aunt Sally, because we don't really have division and addition, subtraction. So notice we do have exponents and multiplication. So we have to do exponents first. So we're going to work on the exponents first. So work on this first. And for the second pair of parentheses, we don't have another exponent. So we don't have to do anything there. But there's another exponent, so we need to work this out first. And there's exponent 6, so we need to work out this first. So first, let's do -3x to the third. That's similar to the example we just covered. So to do that, so I'm going to write down this down here. And again, we have a box with the -3 in there and x in there. So we have to distribute the exponent to both of them. So which gives us -3 to the third and x to the third. And so you put 3 here, you put 3 here. But if it's more than just one single number digit or a single letter, you have to put a pair of parentheses. So if I get rid of box, so it's going to look like this. Okay, I didn't do anything to 2x to the 7, so I bring it down. Now, -3 to the 7th, by the definition of multiplying 3 copies of -3. So -3 times -3 is +9. +9 times -3 is -27. So you can do this part on your scratch paper. And that part right here, that doesn't really have anything to do. So you literally just apply then third power to x, which gives you x to the third. You can drop the parentheses. And next, we're going to bring down, let me go ahead and do that. So I already typed this up. So now we're going to do multiplication here, because between this one and that one, there's nothing. That means multiplication. And that goes back to the first 4 examples we looked at in this video. So you will have to reorganize, put the numbers together and the variables together. So -27 and times 2, that gives us -20 and 54. And x third times x7, and we have 3 copies of x and 7 copies of x. Together, that's 10 copies. So be careful. We're not multiplying them, we're adding them, because it's not 7 copies of 3. It's just 7x and 3x, together 10 copies of x. Okay, so last example will also be very similar. So first we have to work out each exponents, -2xy to the second. So in the box, you have these 3 things. So you apply the exponent to each of them. So that gives us, I did them separately. Same thing here. So we have these 3 things. Negative, you can treat this negative as -1. So you're going to have to apply the exponent 6 to each of them. So I got -1 to the 6, x squared to the 6, and y4 to the 6. So now we're going to apply the definition or the formulas to work this out. Negative 2 squared is negative 2 times negative 2, that's positive 4. So this gives us positive 4. Nothing to do here. You just apply get rid of the parentheses. But negative 1 to the 6, we have to multiply negative 1 6 times. If you remember an example from a while ago, we know the answer should be positive 1. But if you cannot see that, because there's even number of copies, and the reason the answer is positive 1 is because every two negatives make a positive. Every two negatives make a positive. Every two negative makes a positive. So now when you multiply a bunch of positive numbers, you always get a positive. And 1 times 1 times 1 is always 1. So that's why this will give us just a 1, positive or positive 1. And x squared to the 6, and again, this means 6 twos. 6 twos gives us, from times table, gives us x to the 12. And this means 6 fourths. Times table, 6 fourths are 24. And put all of them closer. By the way, this 4 and a 1 can be multiplied to give us a 4. And then let me go ahead and just show you what I typed. So we have, after we multiply, apply the exponents, that's what we got. Now, finally, we can do multiplication. So we're going to multiply 4 and 1 to get 4, and x squared times x12. In this case, it's not 12 twos. Okay, 12 twos will be like that. But we don't have this case. We're having 2x's and 12x. 2x's and 12x's, so we added 2 and 12 to get 14. And for the y's, we have 2y's and 24y's. So add them together, we get 26y's.